We are starting with the types of the inverter. One type is the voltage source inverter and the current source inverter. In the voltage source, there will be a single phase voltage source inverter, and the single phase voltage source inverter consists of the half bridge single phase voltage source inverter, full bridge voltage source inverter. Second type of the inverter is the CSI, is the current source inverter. In this also there will be a single phase CSI and the three phase CSI. We are starting with the half bridge single phase half bridge voltage source inverter. In this, the circuit diagram of the half bridge voltage source inverter consists of a capacitor which is required to provide a neutral point O such that each capacitor will maintain a constant voltage, that is V1, V2, VDC upon 2. Due to the reason that the current harmonic produced by the operation of the inverter are low order harmonic produced by the operation of the inverter are low order harmonic, a set of large capacitor are required. This is the reason why we are requiring the large capacitor. Now in this topology, that is the half bridge voltage source inverter, it has a single latch with two power switches, that is Q1 and Q2. We will see in the circuit diagram. For bidirectional flow of current, feedback diode D1 and D2 are employed in parallel with switches Q1 and Q2. The circuit diagram is shown in the figure. As it is shown that the two large capacitors are there, they are used to maintain the constant voltage, that is VDC upon 2 and VDC upon 2, and the two switches Q1 and Q2. These two switches consist of an IGBT type control switch across which an uncontrolled diode is put in anti-parallel approaches. These switches are capable of conducting bidirectional current, but they have to object only one polarity of voltage. That is why we are using the two switches. These two switches are of the IGBT type. Now the VSI single phase half bridge VSI will operate in the two stage. In the stage 1, upper half DC voltage, that is V1 VDC upon 2, and power switches Q1 are in conducting mode and remaining component are in non-conducting mode, and the current will flow like this in the state 1. During the time period from 0 to T/2, switch Q1 is on and upper voltage VDC is appear across a load as an output voltage VAO. Now in the stage 2, the lower half DC voltage is V2 is equal to VDC upon 2, and power switch Q2 are in conduction mode and remaining component are in non-conduction mode. So the time period of the stage 2 is from T/2 to T. Switch Q1, Q2 is on and the lower voltage is obtained across the load as an output voltage. Now this is the table of the switching stage of the half bridge amplifier. Switching state, when Q1 is on and Q2 is off, so we will get the output, that is VDC upon 2. This is for the stage 1, and for the stage 2, Q1 is off and Q2 is on, and we will get the output minus VDC upon 2. This is the waveform of the single phase half bridge voltage source inverter. This is all about this lecture. Now we will discuss in the later lecture about the full wave single phase full wave voltage source inverter and the current source inverter.